Hey everyone, Ken here. Got another little toy that I've made. Going along the same idea of the homopole electromagnetic motor that I showed in my last video. This is another electromagnetic motor. This one I actually learned to create when I was in Tokyo, Japan. I went to a school up there, high school, and in our physics class we actually made one of these. Ironically enough, I'm making another one for a physics project in college. Alright, so I'm going to go ahead and explain how this works. First, we have here a coil made of copper wire that is covered in enamel, so most of it does not have a conductive surface to it unless you scratch away the enamel, which I have done. On this side here, this little point, all of the enamel has been scratched off all the way around. On this side here, only half of the enamel has been scratched off, so that way the current going through the coil stops and starts repeatedly as this engine will spin. These right here are neodymium magnets that I've just got stuck to some paper clips, as you can see. My power source is a homemade laboratory power supply. I took an old ATX, I think 500 watt power supply for a computer and rewired it for external outputs here. Let me get down so I can show you some of the outputs. So those labels there, depending on the combination of which outputs you're using, you can get a variety of different voltages that are extremely well fine-tuned, as a computer operates on very fine-tuned electric voltages, that the slightest deviation from that can fry your components. So this particular power supply is extremely well mannered, and I'm quite pleased with that. So let me go ahead and flip this on. Alright, so right now electricity is being supplied to these paper clips, but of course it's not spinning, and the reason for that is no current is actually going through the coil. I have to spin it manually, like so, and that will make contact and complete the circuit. This keeps spinning because of the electromagnet field, or I'm sorry, I'm having a hard time speaking today. The electromagnetic field that the coil is creating. When current spins in a circle, like it is doing in this coil, it creates an electromagnetic field. Normally that wouldn't do anything, it wouldn't move this coil of wire around unless it had something to push off of. These magnets on either side of it, the neodymium magnets, are providing that very force to push off of to get this coil spinning. These things can get pretty darn fast. I've been having trouble keeping this one on the rails there, as you can see, but right now it seems to be behaving itself. One thing I have noticed that's kind of interesting is on the corners where the contact is being made with the paperclip rails, I'll occasionally get sparks, which are kind of neat. On this video, I doubt you can see them though. But just a neat little project, figured I'd share with you guys, and to be honest, I'm actually making this video for my group members so I can send it to them so they understand exactly what we're doing. Anyways, thanks for... Oh, I should probably tell you what I'm using for the wires. If I remember correctly, this gauge wire here is, I want to say 30 gauge. It's 10 loops, and I'm running it off of 5 volts. And then those neodymium magnets are just tiny. As you can see, they don't really need to be all that close, because electromagnetic forces can, or rather magnetic forces can act through quite some distance across open air, which is very nice. I have 3 other coils that are, again, 30 gauge, but with 20 loops, and the other 2 coils are made from 22 gauge wire, again 10 and 20 loops. Our project is going to see which one spins the fastest. Anyways, thanks for watching. You guys have a great day.